Hi, I'm Celeste, and I'm going to be helping you with the 2010 AP Calculus AB free response. This is number 5. Got cut off so you can't really see. Alright, so the first question is find g of 3 and g of 2, which is right here. I keep pressing it with my hand, it's moving around. Sorry for that. G of 3. So you're given the graph of G prime, and you're given the basic initial condition, which is G of 0 equals 5. Now, according to the fundamental theorem of calculus, you need to remember when solving for G, when given the graph of G prime, you're finding the area, but you also need to keep in mind the initial condition, just like you would if you had a problem of a boy standing on a cliff throwing a ball. You would need to keep in mind where his initial height was, where the ball initially started before he threw it. So G of 3, I said, is G of 0 plus the integral from 0 to 3 g prime of x dx, which is right here. So basically that area is going to be, I knew it was going to be a fourth of the circle with the radius 2, so I said pi radius 2 squared over 4 is going to give you that area, plus 3 over 2, which is the area of this little triangle right here. And all of that together is going to give you 13 over 2 plus pi. So that's your answer for G of 3. G of 2 is the same thing, and it's the integral from 0 to negative 2, but because you always want the bigger answer on the top of the integral for your b, I flipped it, so instead of 0 to negative 2 is negative 2 to 0, and that's why I ended up with this negative sign in front of the integral. And so G of 0 is 5, and minus the basically the area under this curve from negative 2 to 0 is pi. And that's because we had also found that fourth of the circle in for G of 3. So those are your two answers for A. Your second is right here. It was cut off a little bit. It says find the x-coordinate of each point of inflection on the graph. So again, I've written it out just to kind of like reinforce what I already knew. I wrote we know the point of inflection is when the changes in concavity occur, and so I wrote out the rules that we already knew having to do with concavity and like f prime, f double prime. So we're given the graph of G prime, and we want to know when f, which would be G, essentially, changes in concavity. So we know that when G prime changes sign, or G double prime changes sign, we know that G prime goes from increasing to decreasing because we have those rules right here. And then we'll know also if it's concave up or concave down for just G. So I went back and looked at the graph, and I found, let me erase this so it's not so messy. Okay, I found at 2 G prime. So keep in mind, it's tricky. You're looking for where G prime increases changes from increasing to decreasing, which then is the inflection point of regular g. And that happens at x equals 2, because it goes from decreasing to increasing. And, where's the other one? X equals 3, which it goes from increasing to decreasing. So, those are your 2 points, your 2 points of inflection. And just keep in mind these rules when you're doing a problem like this, because at least for me it looked like a very difficult question from the beginning, but if you can keep those 2 rules in mind, you'll be set. Alright, well, I hope this video helped. Again, this was number 5 on the 2010 AP Calculus AP Free Response Questions.